No, this week no. So recall back. What do you learn last class? What did you learn last class? Huh? Learn about de Broglie. Yeah, the weird relation. What de Broglie said? Wave particle duality. Wave has a particle nature and particle has a wave nature. What is the proof? Wave has a particle nature. Wave has a photoelectric effect. Particle to wave nature, electron diffraction pattern. Okay. Remember the two controversial experiments showing the opposite property. Okay. Okay. Then after the de Broglie, we learn about everyone have wavelength now. Okay. And after that, we learn about line spectra. Okay. Quantum physics able to solve that problem, able to solve the Rutherford model problem. The nucleus is fine, but the electron structure needs some adjustment. Okay. Okay, class. Okay, relax. So the electron found to be got lots of energy levels. What is the proof? The line spectra. Okay. So that's what we learned last class. Okay, now we're going to talk about something called band theory. This is all about the energy levels. After discovery of energy levels, another theory talks about the arrangement of electrons. Okay, in solid, the outer electrons energy levels become smeared out to form a bands. They form like a one area called band. So like this. The outer valences, the outer energy levels. The one go towards the end, they get closer, they form like a very compact energy levels called bands. Okay. Okay, the highest occupied bands is called valence band. This is the valence band where the electron is you can imagine your nucleus is at the bottom here. The nucleus is at the bottom here. This is your nucleus here. This is the lowest energy level. Just now we know electron got lots of energy level. It has something called valence band. The energy level can be grouped together, form like a band, valence band. And there is a forbidden gap, we call it, where don't have any energy levels according to quantum physics. Then later they found there is another energy levels called conduction band. So for atom, for the electron to occupy, it has 3 different bands, it seems. This is beyond what you learned last time. The electron structure, beyond that, the energy levels got 2 different bands. The lower one called valence band, and forbidden gap. Forbidden gap is a region where the electron can't stay there because you don't have any energy levels there. Then later on top, it has another energy levels grouped together called conduction band. So what is the difference between valence band and conduction band? Valence band, if the electron is under valence band, the electron is still bonded to the nucleus. The electron cannot move freely. Okay, they never contribute to current. Okay, no free electron. But if the electron get enough energy, if it's able to jump to conduction band, then the electron can contribute to current flow. Okay, so this is the idea. So for the conduction electrical energy, the electron must be in the conduction band. Okay. Okay, here this diagram, you have 3 types of material: conductor, semiconductor, insulator. All these 3 has valence band, conduction band, but how far away path, that's the difference. The insulator, it seems, has a very huge forbidden gap. A very huge forbidden gap. The gap between the valence band and the conduction band seems very huge. So electron, although receive lots of energy, it can't afford to jump to conduction band. Never contribute to current flow. For conductor, it seems the 2 bands are overlapping. Okay, the 2 bands are overlapping. So you don't need to give any energy. You just apply a electric field, a voltage, current will start to flow because the electron can go from conduction band to valence band anytime. Okay. Okay, that's the explanation we're going to talk about now. The next slide. An electron can have an energy at any level in one of the band, but cannot have any at forbidden gap. No energy level at forbidden gap. Under quantum derivation, people start to believe that derivation after Niels Bohr proved that. Then the quantum derivation later shows this conduction band and valence band. The energy level was separate. So the forbidden gap, no electron can stay there. So insulator, there is a big forbidden gap. No electron occupies the conduction band. The voltage of cell E is sufficient to lift the electron, most energetic electron across the gap. So no way you can conduct electricity. In exam, if they ask O level, if they ask why insulator never conduct electricity, so you say no free electron. 1 mark, get the answer. Now in A level now, why plastic cannot conduct electricity? So you have to say conduction, the band theory. You have to say the plastic as insulator has a huge forbidden gap. The electron from valence band unable to move to the conduction band. Although lots of energy required, but still unable. The electron unable to move from conduction band, from valence band to conduction band. Therefore, no free electron in the no electron in the conduction band. Therefore, no current. Okay, it acts as an insulator. Okay, so last time just free electron, but now you have to tell that forbidden gap is huge for an insulator. So electron unable to jump from valence band to conduction band, therefore unable to flow the current. That's the reason band theory. It is a fact to remember, no calculations. Okay, next, conductor. Conductor, according to the band theory, the 2 bands are overlapping. They are overlapping. Hence, the electrons are free to move about from one band to another band. The conduction band is partially filled with cause the metal is conductivity. And the potential difference applied across the conductor, electron gain energy and move through the metal causes current. So for insulator, from conductor, any movement you can conduct electricity because there is a free electron. There is always electron in the conduction band. Because conduction band, the electron can move conduction band to the valence band anytime. That's why charge density for conductor is constant, never change, because all the electron can be a carrier. They are overlapping. Okay. So in exam, if they ask why conductor conducts electricity, last time it has 3 electron, now you have to see the band. You have to see the conduction band is overlapping with the valence band in conductor. So the electron can move around in these 2 bands. So any moment when a voltage is applied, the electron able to move forward, causes current flow. Okay. Okay, out of these 2 is easy to explain. The first one is next one, semiconductor. It's intermediate. Okay, semiconductor sometimes become insulator, sometimes become conductor. Why? I think you saw this in the diode graph. Diode graph, before 0.7 volt, no current flow. After that, you get a current flow. So the band theory says that semiconductor has a small forbidden gap. Seems very small forbidden gap. So the valence band is full. Okay, come on. Okay, the valence band is full, the conduction band is empty. And when it's at the cool stage, when you put the semiconductor freezer or something, when the temperature is too cold, the electron all will be under valence band. But if you give a sufficient thermal energy, the electron gain energy, it can cross the forbidden gap and jump into the conduction band. The thermal causes more electron have enough energy to jump into the conduction band, increases the charge density, therefore increase the current. That's why for the semiconductor, when temperature rises, charge density rises. For semiconductor only. Semiconductor charge density can change. You just give more energy. Okay. Thermistor, how it works? So now you know the theory now. Thermistor. Thermistor, when temperature rises, the resistance becomes low, current rises. But what is the reason now? When the thermistor get more thermal energy, thermistor made of semiconductor, so electron, this is the story now. The electron get energy, jump to the conduction band, promote more current. Okay, more current. Charge density rises. Charge density rises, more free electron, so more current. So this is the theory behind how thermistor works. Okay. Same story for LDR, light dependent resistor. Also another thermistor, another semiconductor. So how LDR works? Why LDR? Again, LDR, when the light intensity increase, what happened to the resistance of the LDR? Lower. So current greater. So what will happen actually in our theory? When the light is exposed to the LDR, electron get energy from the light, photo light. So electron can jump across the forbidden gap, reach the valence band, conduction band, promote current. LDR is like photoelectric effect, but this is come out from this is not totally released, it's still in the semiconductor. Photoelectric effect, the electrons totally comes out from the metal plate. Okay, so this band theory, it comes out, I think it's gifted mark. Just explain the theory, why there is current flows, why not current flows. Okay, so semiconductor is the tricky one. The thermal excitation is sufficient to move the electron up from the valence conduction band. The thermal causes move the electron enough energy to jump into the conduction band. Charge density therefore increases, current increases. Okay. Okay, so when a conductor heated, its resistance increases. Okay, and conductor heated, its resistance increases. The atom vibrates more. The electron find it more difficult to move through the conductor. That's why the resistance of the conductor rises. But in semiconductor, Resistance decreases with increases in temperature. Why? The electron can be excited up to the conduction band. Conductivity increases. The charge density rises. Intermediate and point is to be C. Charge density rises. Therefore, conductivity rises. Charge density never rises for conductor. It's fixed. But charge density rises in semiconductor when you apply sufficient energy. That's why resistance for semiconductor drops when you heat the semiconductor. Okay, but you heat the conductor, the resistance rises because of what? The charge density never rises, but the atoms are vibrate more severely, so the electron can't move forward. But you might confuse. In semiconductor, is that oscillation of the atom never happens? It do happen. Okay, for a semiconductor, the oscillation of the atom happens, so the electron face difficulty to move forward. But at the same time, the charge density rises. So the charge density increase in charge densities outweigh the problem faced by the oscillation of the atom. So still current rises. Okay. Okay, so that's all about part 1 of quantum physics. Yeah. Douglas, before okay, so still quantum physics. The next part of quantum physics is the application. This idea used where another one is application for quantum physics is X-ray. Okay, X-ray production was unable to explain by wave idea. Only quantum able to explain the formation of X-ray. Okay, that's why X-ray has been placed under quantum physics. Okay, so let's see. Proceed this application. Those who want to do medical field, I think might be useful. Okay, so what is X-ray? I think I told you one of the electromagnetic radiation. X-ray is found coincidentally. Okay, that's why the name given X-ray, X5. You don't know anything about that ray. Just coincidentally, they got the X-ray. And the scientist, I think, introduced the electron gun. The electron was fired to a fluorescent screen. He is testing about that, but unfortunately, there is a photographic plate nearby. When the electron go and hit the plate, the electron was decelerated, and some sort of radiation comes out. We never realized because it's not visible. But the photographic plate changed color. Then he found that there is some sort of rays coming out. So he named it as X-ray. Later found to be very useful. Okay, so production of X-ray. So yeah, X-ray, one of the non-invasive mode of checking before go for any surgery, right? I think we have 4 down there. We have 4: X-ray, MRI, ultrasound, and CT scan. Of course, first the doctor want to go for the cheapest is X-ray and ultrasound. So they are very cheap. X-ray, I think one shot, I think around 30 ringgit maybe. Cheap. Ultrasound maybe 50 ringgit. CT scan 500. MRI 1000 plus. 1000 how much? 1200. 1200. You put dye, another 300 at 1500. Then the doctor's report, another 300, I think. Okay, yeah. So X-ray. So X-ray has long been used to take picture of broken bones. Yeah. So to check any damage to the bones, any damage to the breech, any internal structure, is there atoms are arranged properly, or is there any delocalized atoms? They use X-ray. Okay. To check the arrangement of an atom of a structure, also they use X-ray to check how the deflection of X-ray is used to check how the atoms are arranged. Okay, uses of X-ray in science. Okay, this is the production of X-ray. This is the X-ray tube. Okay. When you go for hospital, I think I'm sure everyone been to X-ray. You lie down on the top. There is a machine. This is the machine. It's you need to know how it works. Okay. Okay. So this is the X-ray tube. When they on the X-ray tube is actually a electron gun. There is an electron gun. Okay. Electron gun is here. The tungsten filament hit the filament. Okay. There is a free electron is produced. The free electron later accelerated towards the anode or cathode. Should be anode, right? Anode. They use anode here. High voltage anode is used. Okay, this is a voltage and high voltage anode here. Made of tungsten. Tungsten, why tungsten? Because very high melting point. So X-ray going to melt the tungsten, melt the metal, because lots of heat energy going to be transmitted. Why lots of heat energy? First of all, how X-ray is produced? X-ray is produced when high-speed electron was bombarded to a metal surface. The kinetic energy of the electron is converted to 90% of heat and about 10% of X-ray. Now they found less than 10% is converted to X-ray. Okay. So how X-ray is produced? When a high-speed electron was bombarded to a metal surface or to an anode, the kinetic energy of the electron is converted to X-ray and heat energy. Majority is heat energy. Okay. So the efficiency of the X-ray tube is only 10%. Okay. When you lie down on the machine, 90% is waste as heat. Okay. So the heat might melt the anode. That's why they found tungsten is the best material to be used because high melting point. High melting point. Okay, so electron emitted on the cathode is accelerated through the vacuum tube to hit the metal block anode. On heating, that 90% energy is converted to heat, 10% is X-ray. The anode has to be cooled by various methods. The anode always need to be cooled. So must have there is a mechanism to cool it. They turn the what do you call the anode? The anode is rotated so that the electron never hit the same point of the metal. Metal is rotated. The anode will be rotated always. Okay. So the free electron is produced by using thermionic emission. We call it thermionic emission. The cathode is heated by electrical means. The electrons are emitted. This is opposite of photoelectric. Photoelectric, light release electron. This one, heat release electron. It's called thermionic emission. Thermal. Okay. Okay. So to produce X-ray, PD between the anode and cathode must be 20 kilovolt to 100 kilovolt used. You want to go for normal X-ray, maybe they put at 20 kilovolt. You go for radiotherapy, okay, maybe let's say someone diagnosed with cancer and after surgery, they go for radiotherapy. Okay, radiotherapy, normally they use X-ray, sometimes gamma, but normally X-ray. What X-ray? More intense, more penetrative X-ray. Or in other words, they say more harder X-ray is used. Harder means more penetrative X-ray. To have more penetrative X-ray means you must use high voltage. Maybe 100 kilovolt needs. When they use 100 kilovolt, the electron kinetic energy is so huge. When it collides with the anode, the type of X-ray comes out. It seems very low frequency, very high penetrative power. So used for radiotherapy. Okay. So doctors know which voltage to be used. The technician, I think, knows which voltage to be used, instructed by the doctor. Okay. Okay. Okay, now theory part. Okay, the production of X-ray. The X-ray is produced. Two main mechanism comes in two varieties. The Bremsstrahlung X-rays, characteristic X-rays. Okay, the main point here is when the X-ray, when the electron go and hit the anode, when the X-ray comes out, the X-ray found to be, the frequency is found to be a range of frequency. See, according to this graph, this all X-rays comes out. The X-rays that you see here, the wavelength is a range of wavelength is produced. And the intensity of wavelength comes out is varies. The middle wavelength got lots of intensity, but some particular wavelength has a very high intensity. The spike in the graph, very high intensity. Only particular wavelengths got very high intensity, the spike. In exam, they want you to explain this graph. Why it has a range of wavelength? Why it has that spike? And why it has a certain minimum wavelength? These three. If this comes out, explaining the graph could be 5 to 6 marks question. Explain why the X-ray graph is like this, the emission. Okay, this is the reason we're going to do now. Okay, why the wavelength is in a range? Okay, that's the next slide. Oh my God, lots of word. We go to the one highlighted. Okay, the one highlighted. Okay. Okay, class. So you see the first diagram here on top here. This diagram. So this diagram, when electron accelerates, it emits radiation. When a charged particle accelerates, it emits radiation. Like imagine electron like a spaceship get into the metal. In metal got lots of atoms. Every atom like a planet for that electron. So each planet has an attractive force because center is nucleus. This guy is negative. So when you go close to the atom, what happens? They will about to move in a circular path. They try to trap into the nucleus. Okay, when they move, they will about trap to the nucleus attractive force. So the electron tend to move in a circular path and like that for every atom. So it slows down. Why it slows down? When you make a circular path, partial circular path, it accelerates. So according to Maxwell, when any charged particle accelerate, its energy going to change to EM radiation. Radiation comes out. In this case, X-ray. X-ray comes out, and the electron slows down. Okay, so that's the idea has been used. Okay, so first idea to explain why it has a range of wavelength is first direction velocity. First, you have to say that the the charged particle accelerates, emits radiation. That's the first mark, and that's the M1 mark. M1 mark. That means you never tell that, you won't get any answer marks for after the next explanation. Okay. The first main explanation is what? Charged particle which accelerates, emit radiation, ionizing radiation, emits EM radiation. Okay. Any charged particle accelerate, emits EM radiation. Okay, that's the first point. Change in energy radiates as electromagnetic radiation, vector quantities of directional velocity. Yeah, electron is not destroyed, it can go. Okay, next, the electron, when go to the first atom, let's say it accelerates, it loses 20% of energy, 80% of energy is still there. So when you go to the next atom, it accelerates again, move in another circular path, it loses some energy. So it might go for 5 or 6 atoms go around before it come to rest. So how many types of acceleration it might have? It might have a range of acceleration. The electron will reach a range of acceleration. First time the acceleration is huge, maybe after that is small acceleration. So every acceleration give out X-rays. X-rays comes out. Okay. How powerful the X-ray comes out, it depends to how big is the acceleration. The bigger the acceleration, the X-ray comes out will have a high frequency, lots of energy. Okay, so when the acceleration towards the end becomes slow down, the X-ray comes out with a smaller frequency, less energy. Okay, so why the X-ray is in a range? First, charged particle when accelerates give out EM radiation. Second, the electron makes a series of collision, or series of collision before come to rest. Okay, therefore the electron has a range of acceleration. The electron has a range of acceleration. Okay, this produces a range of wavelength of X-ray. A range of wavelength of X-ray is produced. Okay, so when charged particle accelerates, give out EM radiation. When the electron collides with the metal, electron experience range of acceleration. Range of acceleration, therefore range of wavelength of X-ray is produced. Okay, there's a 3 marks question to explain the range of wavelength. Why X-ray comes up from the tube is as a range of wavelength. Which wavelength is very useful for the imaging? Which wavelength is contribute to the imaging? The one high wavelength or the short wavelength? Which can be penetrative to the thing? The short wavelength. The short wavelength is the one useful for the imaging, which contribute to the imaging. The long wavelength reach your skin, but it cannot penetrate. So it's a waste for us. But at the same time, it damages your cell. Okay. Yeah. So the range of wavelength comes out from a tube is a negative setback for us. We need only particular wavelength, but a range of wavelength comes out from the tube. Okay. The short wavelength is the one very useful. Okay. So next time they ask why there's a range. Okay, next. Okay, next let me check. The next is the short wavelength, the shortest wavelength. Why there is a cutoff point? Why there is a short wavelength? Explain this part. Why there's a short wavelength? Why there is a minimum wavelength? There is a minimum wavelength comes up from the X-ray. So the reason is where the maximum energy relates to the kinetic energy of the electron. The electron is not destroyed; it can undergo multiple interaction. Even initial interaction will vary the minor major angle attacks. Oh, this slide never explained this. The last point is explaining that. When an electron make one head-on collision with an atom, one head-on, just you see millions of electrons get into the metal. Some electron make 5 collision stops. Some take many collisions then stop. There is one particular, if it's unlucky, straight go to the head-on with an atom of a metal. So what happened? We just make only one collision. Then what happened? All the energy converted to one single photon. Change to one single photon. That single photon will have lots of energy or little energy. Will have lots of energy. So therefore, the X-ray produced by this head-on collision will be the shortest wavelength. Will be the shortest wavelength. Okay. So the reason here, that's why they say, you see here, they put EV equals to hc over lambda. Why they put EV? EV comes from where? How the electron gain kinetic energy? From the electron gun. The electron gun, you apply a voltage. You apply a voltage from the anode cathode, sorry. That voltage, the 20 kilovolt. The electron gain kinetic energy because you pull the electron by anode, but by using a voltage. So what is the gain in kinetic energy of the electron? It's same as the work done by the field, right? EV, QV actually, EV, E times V. So the EV is the kinetic energy of the electron. So all the kinetic energy of the electron is converted to a single photon. That's why here the formula is EV equals to one photon. Why we learn quantum physics? Why we learn X-ray under quantum? Because the X-ray uses hc over lambda concept, the photon concept to explain. That's why we learn X-ray under quantum. So EV equals to hc over lambda. So you get the wavelength, the shortest wavelength ever produced by the X-ray tube for that particular voltage. So now reason is what? Why you have a certain minimum wavelength? The reason is when that happen and the electron make a head-on collision, all the kinetic energy of the electron converted to one single photon, which produces the shortest wavelength. Okay. So again, when the shortest wavelength happens, when the electron makes a head-on collision with an atom, all the kinetic energy converted to one single photon, responsible for the shortest wavelength. Okay, so that's the explanation for which part? The shortest wavelength. Okay, 3 mark for the range of wavelength, maybe 2 mark for the shortest wavelength. Now the difficult one to explain is the spike. Why it has a certain maximum velocity? Why there is maximum velocity, maximum intensity happens for a particular wavelength? Okay, the reason according to quantum physics they're explaining is, okay, when I was in Form 6, we learn a different theory to explain. But in A levels now, Cambridge giving another explanation. Explanation posted here is the one what I have learned. Okay, explanation by the Cambridge is different. Okay, the spike, according to what I have learned is the electron going into the metal atom. Okay, the atom also has electron going around in that atom. Okay, so this incoming electron might have chance to collide with the initial electron. Can collide with the initial electron. Okay, which shell is going to collide? The most initial electron. Okay, more chances to collide. Okay, why the initial electron? You see, this is the nucleus. You have one electron going around here. You have another electron going around here. Another electron here. Okay, so when incoming electron, one incoming electron comes in, I think the probability to meet up the outer shell electron is very small, right? Because make a big ground, it make a very big ground. For time this electron and this electron to meet up, I think the probability is not that big compared to hitting the initial electron. Initial electron make a small circumference. I don't know how many times you're going to meet up the same point here. Many times. So high chance to collide with the electron, the incoming electron. So the reason for the spike is the electron might collide with the initial electron of the metal. So what happened? According to quantum physics, what will happen? Some energy will be transferred to the initial electron. Okay. So when the initial electron receive energy, what will happen to that electron? Will jump to the high energy level. That's what we learn under line spectra, right? Okay, so when electron receive energy, the electron will jump to the high energy level. Then after a short while, what will happen? After cool down, the electron will come to the ground state. So it releases photon in X-ray region. So you get X-ray. Okay, so that photon is very common, high intensity. That means that happens very frequently. Okay, that happens very frequently, causes the high intensity in that particular wavelength. Okay, this wavelength they say exactly same as the characteristic of what? Characteristic of the energy level of the atom. Let's say this is the nucleus. The initial electron is here. It go jump to this level. This is E2. The energy, the ground state. Let's say E1. So when the electron comes down, the photon comes out is actually what energy? E2 minus E1. E2 minus E1 equals to what? What is the photon energy formula? AC over lambda. The wavelength, the photon which comes out, this is the wavelength comes out. Okay, so that wavelength is very common. That means it happens quite frequently. The electron collide with the initial electron. That's what Cambridge explaining. Okay, but what I've learned is last time, and other boards are doing still, the electron go and collide with the initial electron. The initial electron receives knockout, comes out from the atom. Okay, Then what happened? Electron from the higher energy level start to fill up bottom energy. So you have lots of tennis ball, you pull out one tennis ball in a box, you pull out the one tennis ball at the bottom, so all like rearranging, right? That's what happened. What I've learned and other boards learning now. Okay, but Cambridge says that electron collide the initial electron, the electron excited from the low energy level to high energy level, de-excitation releases X-ray, which is responsible for the spike. Okay, so that's your Cambridge answer. Okay, that reasoning was explained in the word file. You go to there's the word quantum physics. This one. Okay, basically you scroll down the word file. So here, production of X-ray. So this is the graph. The graph is the explanation. This exactly from the Cambridge notes. This is what they explain. They said, you see, let me go through again. Whenever a charged particle accelerated, electromagnetic radiation is emitted. Most important point before you explain, you must tell this. The greater the acceleration, the shorter the wavelength of emitted radiation. Yes, big acceleration produces a short wavelength. Then electron has a continuous distribution of acceleration. It has a range of acceleration. Okay, 1 mark. A continuous distribution of wavelength, X-ray is produced. Range of wavelength is produced. 3 marks question, this one, to explain the range of wavelength. Okay. There is a minimum wavelength, cutoff wavelength, where the whole of the energy of the electron is converted into energy of 1 photon. That is kinetic energy EV equals to hc lambda, responsible for the minimum wavelength. This is another 2 mark. Okay. Highlighted points. And the last one, yeah, this is the peak. The peaks correspond to the emission line spectrum of the atoms of targeted atoms of the target. The electron that bombarded the target excite orbital electron in the lower energy level, and the subsequent de-excitation electron gives rise to a line spectrum. Line spectrum is the photon comes out like X-ray. So the initial electron has been excited, de-excitation produces a line spectrum, which is responsible for the peaks. Okay, the peaks. So this entire explanation can carry around 7 marks. Okay. So this paragraph you have to memorize. This full memorize. Memorize this. Okay. So 2 minutes again, 1 round. Why you have a range of wavelength? Electron makes a series of before that, what you have said? A charged particle accelerates, give out EM radiation. 1 mark. So the electron makes a series of collision before come to rest. 1 mark. Okay. Therefore, series of acceleration. Series of acceleration give a range of wavelength, responsible for the range of wavelength production. The cutoff wavelength happens when the electron makes a head-on collision. All the energy converted to kinetic energy, all the kinetic energy converted to one single photon causes the shortest wavelength. Okay. The peak happens what? The peak happens when the electron make a collision with the initial electron. The electron will be excited. De-excitation produces a line spectrum, which is responsible for the peak. Okay. So this X-ray production only can be explained by using the concept of photon and energy levels. That's why under quantum physics. Okay. Okay, first so the another few slides. So this diagram tells the anode need to be rotated. Anode is either water cooled or is made spin rapidly so that the target area is increased, so cool down because lots of heat energy generated. Okay, this is the production part of X-ray. Okay, so how X-ray produced? When high-speed electron was accelerated towards an anode, all the kinetic energy of the electron is converted to X-rays. Okay, the kinetic energy of the electron is converted to X-ray and heat. Sorry, heat. Okay, that's how X-ray is produced. Okay, so too much of facts today. Okay, so I don't want to drag further. Okay, let's do some questions. I stopped discussing about X-ray. So what you learned today? You learned about before X-ray, the band theory. You learn about band theory, the solid semiconductor, sorry, the conductor, semiconductor, and insulator. Then we talk about X-ray. Okay. Before that, we learn about de Broglie and line spectra. Okay, class. Still have another 5 minutes. Okay. Hey, class. One question. One question, then we stop. We have another 5 minutes. Okay, the question, what I missed out last class is I never do any question about the line spectra. Yeah, we teach you some line spectra energy. Okay, let's redo one question about the line spectra. Your Nilbo. Okay. So November 2, question 2. Emission spectrum of hydrogen atoms have these 3 wavelengths. Emission spectrum. Emission spectrum means electron goes down, goes up. Emit photon. That means the electron is from high energy level to low energy level. So emit photons, so emission spectrum. So 656 nanometer, this is the energy. 486, they're asking how much is the energy. How do you find this energy? Come on. What formula do you use? ACO lambda. So you use the 486, you get this energy. Okay, then complete by calculating the photon energy. So this is no problem. ACO lambda will do. Next, 2 energy levels given, lower ground and 3.03 times 10 to the negative 19. From here to here, the transition, it gives 656 nanometer of wavelength, not millimeter, nanometer. Draw one further label energy level and complete the diagram with arrows to show the energy change of the other 2 wavelengths. Okay. Draw another line to show another 2 transition of the wavelength. Where do you draw another one line? Okay, go back to the table. So this is the table. You see the table? Table got 656 nanometer, 486 nanometer, 1088 nanometer. Okay, 656 is here. You need to draw the 486 and 1880. Where do you put another energy level? In between these 2 lines, on top of this line. In between this line or the top of this line. You draw here, you draw here or here. 1 or 2. 1 or 2. Should be 1, right? So you must draw 1. Then only you can draw another 2 line. Where's the another 2 line? 656 is here. From up to down will be, what wavelength is this? This 1880. The longest energy difference should be produced short wavelength. So 400 something, the 400 one. This will be 1880. So you must draw energy level on top. You must put the energy of that. Energy here should be energy of what? Energy of the 400 nanometer of photon energy you have to place here. Okay. So all the arrow must go down. Okay. So give a try some more questions from Tasif. Okay, we stop here. Okay. So tomorrow we continue with the X-ray.